right, what this question means, this question's kind of hard to interpret. What it means is, if we've got two polynomials, let's say, for example, the first one is something like that, and the second one is something like that. And we figured out the first minus the second, then the points where they intersect is where the first minus the second equals 0, where they're the same thing. So they intersect, let me write this, intersect when P of x minus Q of x equals 0. So what we do is we find f of x, which we're deciding is this thing, and we're going to find its zeros. We're going to, factorize it to find the zeros. Now, sometimes you'll have a graph, you'll have the situation where, I'm just going to do this one fairly small and rubbishly. So let's say I had this, and let's say I had something like that. This point, where it touches, but doesn't actually cross through, has multiplicity greater than 1. So we might end up factorizing and end up like with an x plus 1 squared or something. Well, you'll see this when we do it in real life. So the examples I'm going to go through are A and well, let's start off by going through A, and then I'll see if we've kind of covered everything in A. So let's have a look at A. Let me copy it. So f of x is always going to be P of x minus Q of x. It's going to make your life easier if you choose the one with the highest degree to be P. So we've got 2x cubed take 4x squared plus 3x plus 1. That's P of x minus Q of x, which was x cubed plus, oh no, that went weird, plus x squared take 8. So we've got, we didn't need these brackets in this first one, 2x cubed take 4x squared plus 3x plus 1 take x cubed take x squared plus 8. Which means we've got 1x cubed, we've got negative 5x squared, we've got 3x, and we've got 9. Okay, now we want to factorize this. Factorize. I'm going to try the things that multiply to give positive 9. So 1 times 9, negative 1 times negative 9, 3 times 3, or negative 3 times negative 3. So let's actually see which ones of these come out as zeros. So f of 1 equals, well, we've got 1 cubed take 5 times 1 squared plus 3 times 1 plus 9. 1 take 5 plus 3 plus 9, not 0. What about negative 1? Negative 1 cubed take 5 times 1 squared plus 3 times negative 1 squared, sorry, negative 1 plus 9. Negative 1 take 5 take 3 is negative 9 plus 9 equals 0. Therefore, x plus 1 is a factor. Good, we've made a good start. Okay, let's try all the rest. F of 3, f of negative 3, f of 9, f of negative 9. We're going to try all of these to see what comes out as factors. And we discover that plus 3 equals 0, but none of the others do. So f of x, which is this x cubed take 5x squared plus 3x plus 9, equals some kind of number times x plus 1 x take 3. I know x plus 1 times x take 3 is x squared plus take 3x plus x, so take 2x take 3. So what I'm going to do is I've got my x cubed take 5x squared plus 3x plus 9 divided by this thing, x squared take 2x take 3. Okay, x to the 1, okay, x cubed, take 2x squared, take 3x, subtract and dragged, 0, negative 3x squared, plus 6x plus 9, divide, take 3, multiply out, take 3x squared plus 6x plus 9, subtract, obviously going to come out as 0. Okay, so our third factor is this one. So we know f of x is x take 3, x plus 1, x take 3, like that's this one. Which means we've got x take 3 appearing twice, so we've got x plus 1, x take 3 squared. So, they cross over at x equals minus 1, but are tangent, which means they touch but don't actually cross, it bounces back, at x equals positive 3. And we knew that because the positive 3 was the squared one. The rest you're going to do like that.